Can you guys hear me? Okay. Thanks once again, Bunty. Okay, we will start right away. Can you see my screen? Oh, thank you, boss. Okay, see, just recapping whatever we have discussed just for a minute or so. So, we have this kind of problem and try to figure out what are implicants. So, literally anything you can call it as an implicant. Okay, so if I take, let's say, this minterm or this minterm, let's say, if I take this, what is this minterm? This minterm corresponding to just ABC, right? This minterm is A, B, C because here A value is 1, B value is 1, C value is 1. It's a SOP form, so ABC. So ABC can be a minterm, I mean implicant. Then I have this implicant like this. And this we have seen already. What is this? A bar uh, C. A bar C can be an implicant. Then I have this one more. What is this? BC. BC can be an implicant. Then this is AB. Okay. So literally anything you can call it as an implicant. Now, what is a prime implicant? An implicant is said to be a prime implicant if it is not completely present in some other prime implicant, some other implicant, right? Now, if you take, for example, A bar C, A bar C is not completely present in some other implicant. So, A bar C can be a prime implicant. Then BC, if you take BC, now if you take BC, BC is partially present in A bar C and partially present in AB. It is not completely present. So BC can be prime implicant. Then AB, similar to AB, AB is also a prime implicant. But look at ABC. ABC is here, right? AB. This is ABC. This is AB. Correct? This is ABC, right? Now, if you look at ABC, ABC is completely present in AB or ABC is completely present in BC. So, ABC will become non-prime. Okay, this is very, very important. It is completely present in some other. Okay, now what are the essential primes? A prime implicant said to be essential prime if it has at least a single one which is not present in any other implicant. Now we look at A bar C, it has a 1 here which I am pointing right now. Okay, let me use laser pointer. You look at this, A bar C has a 1 which, I mean, it has at least a single one which is not present in anything else. Okay, so A bar C will become essential prime. And if you look at AB, it also has a 1 which is not present in anything else. But you look at BC, BC is a prime, but this one is present in A bar C, this one is present in AB. Okay, so BC will become redundant prime. Okay, so let me write it. So A bar C becomes essential prime, AB becomes essential prime, BC. It doesn't have at least a single one which is not present in anything else. So it will become redundant prime. Okay, this is what summarized everything, whatever known about implicants. Okay, you have any questions? If you are clear, then we will solve this problem. This problem I asked you to solve last week, right? Okay, so we have solved it. I just recapped it, whatever happened in the last week. This also we have seen. Okay, so solve this K-map. Please unmute yourself and then talk. Huh? Okay, any answers? Option A, okay. Yeah. Hmm. Hmm. No, we discussed about prime implicants and essential prime. Whatever happened in the last week, I just summarized. Okay, only this much I discussed. Yeah. Start solving the problems. Anyways, I keep coming back to that same slide again and again. Okay, don't worry. Yeah? Okay. So let's see. First of all, this is a bit tricky. Okay. Why I'm saying that? You see this code? It has to follow gray code, right? 0001. Then what is this? The order is wrong here, right? So we need to rearrange it. So one has to quickly check. Maybe it will take hardly 10 seconds to check it. Okay. Quickly check whether they are in the order, proper order or not. If they are in the order, then we can go ahead with the other things. So one. Okay. Nothing is there in this, right? Only one here, right? Now you start pairing and all. First you check for group of 8 ones, not possible. 4 ones, not possible. 2 ones, yes. This pair I can take. What is this pair corresponding to? A bar, B bar. Then I can take this, correct? What is this pair corresponding to? A bar, C bar. Okay. So the answer is F is A bar, B bar plus A bar, C. Because it is SOP form, right? You will get a SOP form. You are working on ones. If you work on zeros, you will get a POS form. You should write everything in the POS form, right? That we have discussed extensively. And you come to the channel, my channel there, and then there are a lot of SOP terms, min terms, max terms, how they are derived in detail, everything is there. Okay. So what is answer for this? A bar B bar plus A bar C bar. What is this? A bar C bar. A bar B bar plus A bar C bar. Option B. Guys, can you guys mute yourself? Okay, thank you, Tanmay. Yeah. Okay, next problem. Solve this. Which one? Ah, yeah. Hmm. Me. Nothing. I just shifted this column this side, this column this side. That's it. Yeah. Okay. This problem. This is very easy actually. Just to get into the motion, I just gave you this. So you can say group of 8 ones. If you think group of 8 ones possible, not possible. Group of 4, yes. This I can take. Sorry, this group. So you check. I think you might have checked the gray code whether it is following or not. Like 0 1 following 0 0 0 1 1 1 0. Very good, nice. So what is this corresponding to? In these four, uh, in these four rectangles or in these four boxes, A is changing and B is also changing. Only C is not changing and C value is 0, so it is C bar. Then you can take one pair here and that will complete covering all the ones, right? So what is this? A is A bar, then B bar. Okay. So if I combine these two, A bar, B bar plus C bar, right? That's the answer. Okay. That's very straightforward and then doing it. Let's go to next problem. Solve this. This was a 2 mark question actually in one of the gate. Because almost all the questions are gate questions only, but this came very recently. And this problem also will determine, you know, how much you know about EPIs, RPIs, and all those things. First 10 seconds, you quickly check whether the gray code is satisfying or not. If they are there, then go ahead for solving. Option A, okay. Okay, let's see. Okay, so what you will do, you will try to find group of, there are 16 cells in this. So 4 variable K map. A group of 16 ones you will see and nothing is available. So you will take a group of 4. Straight away you got this. Hmm? And any other group of 4? No. So you'll take this one, group of 2, group of 2, group of 2, group of 2. Hmm? So let's number them. This is 1. Hmm? This is 2. This is 3. This is 4. And the bigger one is 5. Okay. So now whenever you are writing the answer, right, you have to consider all EPIs first. All EPIs. And see whether you have covered all the ones or not. If you have covered all the ones, you leave it. You leave the other things. If not, then you consider RPS and then try to see we cover the all the ones, right? So I can write F as 1 plus 2 plus 3 plus 4. Here is the catch. By covering 1, 2, 3 and 4, you are essentially covering all the ones, right? What is a 5? 5 is a redundant prime implicant. You go back to this slide, correct? You see this, you see this BC doesn't have a at least one which is present to itself, right? This one is shared by A bar C, this one is shared by AB. So that's why we called BC as a RPA, right? I mean redundant prime implicant, no? Similarly, you look at 5, this 5 doesn't have a single one on its own. It is shared by others. 1, 2, 3, 4. So obviously 5 will become RPI. By just combining 1, 2, 3, 4, you are covering all the ones. So what is the point of keeping 5? So if we write the answer right now, what is 1 here? 1 is in these two, right? B is changing, A is not changing. So I write A, and in that column C and D are constant. A, C, D plus second. Where is second one? Is here. This is the second one. In this row, A is not changing, B is also not changing, and C is also not changing. Plus 3. 3 can be written as A, B, C bar. 4 can be written as what? A bar, C bar, D. So ACD, where is it? You can look at it. One second, one second. A bar BC, then ABC bar, then A bar C bar D. Option B is the right answer. Yes, sir. Tell me. Yes, obviously, no. Because the question is what? Simplify, right? Here you see. You need to simplify. Means you have to reduce as many literals as possible. Correct? Otherwise, what is the point of doing all this, right? And surprisingly, there is a consensus theorem also you can apply. Suppose if somebody says option A is right answer, let's assume, okay. Somebody says option A is A bar C bar D plus AB C bar plus ACD plus A bar BC plus BD, correct? Now what I'll do is simple rearrangement. You can think. From these two, I can take B common, okay? B into AC bar plus A bar C plus D into A bar C bar plus AC plus BD. See, if you say, I have solved a Boolean expression using the Karnaugh map and you stated your final answer, then nobody should be able to simplify that. If somebody has done simplification of whatever the answer you said, then you have not done it in a Karnaugh map rules. That's what the point I'm trying to say. Now you see this. This is XOR operation, right? B into A XOR of C plus D into A XNOR of C plus BD. Correct? Does it? That's very simple, na? This is like looks like a consensus theorem. A P1 plus A bar P2 plus P1 P2. Correct? So you can ignore P1 P2. Obviously, what is this? You are going to get this one, right? Means if somebody said A is right answer, A is the right answer, whatever the answer they stated, I could able to reduce BD also from there by using consensus theorem. Correct? So eventually I ended up getting to this. Why you got it? Because you considered RPA, which is unnecessary right now. Okay. So that's how the thing is. Okay. This I have proved it using consensus theorem. So, you solve this problem. In the K-map, number of, today it's all about essential prime implicants and all those things. We have some interesting questions also coming up. So, in the K-map, number of essential prime implicants of the function are, first 10 seconds you need to check whether it is in the K-map order, like gray code order or not. So 00011110 following the gray code, 00011110 following the gray code. Look for 16 ones, group of 16 ones not possible, then group of 4 ones possible, right? Please unmute your mic and then you can speak it out. Okay, option A. Yeah, somebody saying option A. Okay, let's see. Group of 16 ones possible? No. Group of 8 ones not possible. Group of 4 ones? Yes. So you can group them like this. These 4 ones you can group. This is, let's say, 1. First prime implicants. See, we always find out prime implicants, then we will see whether which one is essential, which one is redundant, depending on how many number of ones are covered. If EPIs cover all, I mean, essential prime implicant cover all the ones, then you no need to worry about RPI the way it happened in the last problem. Suppose if there are something left over, then we have to consider one of the RPA, whatever makes sense. Okay. So then group of 4 ones are over, then anything else is possible? No. Then, okay, this is the second one, third, 4. Anything else possible? 1, 2, 3, 4. Now, question is not about prime implicants, it's about essential primes. Now, look at the first prime implicant. Does it have a single one which is not present in anything else? Yes, here it is. So, first one is an API. Second one, yes, it is also an API. Third one is also an API. Fourth one is also an API. Okay, so option A is the right answer. In the SOP function, the prime implicants are sigma 2, 3, 4, 5. So you need to have three variable k map. Zero one, 0 0 0 1 1 1 1 0, and this is x, this is y, and z f. So what is the binary equivalent of 2 in 3-bit form? Because the three variables are like 0 1 0, right? 0 1 0. Where is 0 1 0? 0 1 0. Here it is 1. Then 3 is equivalent to 0 1 1. 0 1 1. Then 4 is 1 0 0, binary equivalent. 5 is 1 0 1. Where is 1 0 1? 1 0 1. Now group of 8 ones not possible. Group of 4 ones not possible. Group of 2 ones, yes, this is one possibility. This is one possibility. That's all. Only those two exist. Then what is this? X bar y. This is x y bar. So x bar y and x y bar. X bar y and x y bar. This one, option A, is the right answer. Answer this. Simplified form of f is dash, where x denotes the don't care. Just give me a minute, guys. Let me turn on the fan. Yeah, I'm back. Let me know your answers. Yeah, any answers? You shouldn't take more time. Hello? Okay, 0. Okay, right. So answer C is right answer. Shall we move to next problem? You want me to explain? Explain. Okay. So I will definitely do that. Okay. So if you draw the truth table or write the truth table for this function, three variables are there. A, B, C input variables. F is an output variable, right? How many combinations? 8 combinations possible. 4, 5, 6. So if I write the combinations, I'll tell you why I'm writing this. 0 0 1 0 1 0 0 1 1 1 double 0 0 1 1 1 0 1 1 1, right? So if ABC is 0 0 0, F is going to become 0. That's what they are saying, right? If ABC is 0 0 1, F is going to be 0. 1 double 0 also 0. 1 0 1 is also 0. What about other combinations? What about this combination? This combination? This combination? This combination? Means, yeah. Okay, what does it mean literally in terms of logic value? Means you can consider as anything, right? Anything means any logic value, right? In such a way that F will be simplified, not too complex, not to make it complex. My means what could be the reason is this input combination doesn't even occur at the input side. Let's say I have a block, okay? This block is this A, B, C, F. Why this don't care is what exactly would have been happening is this ABC equal to 0 1 1 or 0 1 0 1 1 1 1 1 0 may not even occurring at the input side. They don't even occur, don't occur. Or this block doesn't process those. That means F don't really care about these combinations. That means I can take whatever I want, correct? So it can be anything. So I can take 0, 0, 0, 0, or I can take 1, 1, 1, 1. What should I take? Should I consider 0 or should I take 1? Means if I take 0, I will take a more simplified form of it, right? Correct? If I consider all these as zeros, okay, then F will be more simplified than considering 1. So let's consider all don't care as 0. If I consider all don't care as 0, then it's a group of 8 ones. What is there everywhere? All 0. Means F is equal to 0. Option C is the right answer. That's how you need to understand. Right? Literally don't care means you can say that these combinations doesn't even occur at the input side, or the block doesn't even process them. So it doesn't even bother, it should not even bother you. Correct? Yeah. Next, for an n variable function, the maximum number of essential prime implicants are dash. For this problem, what you can do is you take n equal to 2, n equal to 3, n equal to 4, like that. You can cross verify, cross check and then verify. See, there are a lot of problems which are really straightforward to solve. So what I did is I just picked up some of the problems which I think that they are little tricky. Unless otherwise you know the basics, you might not be able to answer. So I just picked up those problems and then we're trying to solve it here. Option D. Yeah. Let's see. See, for this, let's take n equal to 2. Two variables are there. Okay, A, B, and this like 0, 1. This is gray code, right? So I can have any number of patterns for this to exist. So I can just put this pattern. This is a good combination. I have one. This is essential prime. This is also the essential prime. I have two essential primes. So if I put n equal to 2, 2 into 2 minus 1 is 2. 2 by 2 is 1. So this is ruled out. 2 power 2 is 4. Okay, this is ruled out. 2 power 2 minus 1 is 2 power 1, that is 2. So still chance of A and D, right? Let's go to n equal to 3. N equal to 3. This is A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Then similar zigzag pattern we can follow. This is the best way of getting essential primes. So how many? 1, 2, 3, 4. 4 APIs. If I say 2 into 3 minus 1 is 4, 2 power 3 minus 1 is also 4. Okay, no problem. Let's go to n equal to 4. 4 variable came. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Again, same zigzag pattern you can follow, right? 1, 1, like this. Right? So this is one API, this is one API, this is one API. Because no group of 2s are possible, group of 4 ones are possible, group of 8 ones are possible. So overall, 8 are possible. So if I put 2 into 4 minus 1 is 6. So option C is ruled out. Option A is ruled out. Obviously 2 power 4 minus 1 is 2 power 3, that is equal to 8. So option D is the right answer. Now, next question. Yeah. Hey guys, can you mute yourself? Unless otherwise you have a question. Okay. For the K-map shown in the figure, non-prime implicant is dash. For the K-map shown in the figure, non-prime implicant is dash. Option B for Bombay. Okay. First, start grouping it, forming. They also call it a quad, square, pairs, and all those things. Okay. So try grouping group of 8 ones, then 4 ones, then not possible, then 2 ones, then go for single ones, the one which we have seen last time. So group of 8 ones possible? No. 4 ones? No. 2 ones? Yes, possible, right? Pair. First of all, check the gray code 00011110, right? 01, correct. So this is one pair. This is another pair. Correct. This is one more pair. One more. Not a pair, just a single one. Correct. So we have identified this, right? What is this? Actually, with what is this implicant? A, B bar, C bar. This will become EPI also, essential prime implicant. This is not present anywhere else, right? Then this one. Then this is BC. Okay, that also will become EPI, right? So and this one is A bar B. What is that? That will also become EPI. Okay, so now you found EPIs. See, from the K-map, you will identify EPIs and RPIs by doing large number of grouping of ones, right? You may not essentially find non-primes, right? Now you check the answers first of all. First answer is A, B bar, C bar. What is this according to us? EPI, correct? That cannot be an answer. Then B is A, B, C. Okay, so where is A, B, C? A, B, C is here, correct? A, B, C, I can say like A, B, C is completely present in BC, correct? ABC is completely present in BC. Then what will happen to ABC? ABC is called as what? Not even a prime or non-prime. It's not even called as a prime implicant. Okay, it's non-prime. Okay, so option B is the right answer. We know this BC also. This is BC is EPI, A bar B is EPI. Okay, this we have found out already. This is EPI, EPI, this is EPI. Okay, so option B is right answer. Yeah. For the K-map shown in the figure, find the correct answer. 1, 2, 3, 4. They have grouped something and then gave it to you. And you need to find whether all are APIs, 2 are EPI, 2 are RPI. Then what is that EPI, RPI? Then NPI is non-prime, PI is prime implicant. Find out. First check the gray codes, just 10 seconds, take out and then just see whether they're in gray code, following the gray code or not, all the cells. If yes, then proceed with our procedure. Option B for Bombay or D for Delhi? Hello? Hey guys, can you hear me? Oh, I was muted. Okay, can you guys hear me now? Okay, somebody said option A, option C, B for Bombay. Oh my God. Option A, option B, option C. Ah, someone say option D also. Done. Done deal. Just I will give you like 2 more minutes. Think about it. Try to see whether your concepts are you are applying properly or not. Definition of EPI is fitting into 1, 2, 3, 4 or not. And then let me know. I'll just give 2 more minutes. Just think about your answer. If the answer is same, then you can be with that. Otherwise, you can change. In gate, you cannot do because minus 2 by 3, right? Oh, I'm not sharing the screen. Oh, you guys can see the screen, right? Yeah. So, anybody change their mind? Okay. Now, let's do one thing, okay? I'll take a new slide. Pairing. This is the first one. This is the second one. Third one and fourth one, right? Yeah. See, generally, okay, I'm just redrawing the same thing again. Let's go with our workflow. Then we will see. First, we will try to find out, okay, prime implicants. Then we will see what will be there in there, right? One, one, one. Now, what is the first step that you do? You look for group of 8 ones, right? Not possible in this case. Then you look for group of 4 ones, right? This group. Hmm? Then this one, correct? Now, 2 has, this is also 2, right? This is 2, this is 3. 2 has at least one single one, which is not present in anything else. So, 2, I can say EPI, essential prime. 3 also has at least a single one, which is not present in anything else. So, 3 also, I can say it is an EPI. What is 1 here? Let me take a green color. Now, 1 is this. Now, there is a bigger implicant like this. In that, 1 is present. So what is this one called as? Non-prime implicant. Yes or no? Because one is completely present in some bigger implicant. Similarly, 4 also. 4 is also completely present in a bigger implicant. Correct? So 1 and 4, these are called as non-prime implicants. Anybody has any question here? Simple, right? Right? So 1 and 4 are non-prime implicants. 2 and 3 are EPIs. Right? 1 and 4 are NPIs. 2 and 3 are EPIs. So option C is the right answer. I am sure people are little bit getting shocked here and there, but still, anyways, this is good. This is actually, that is how we learn the basics again and again, right? So, are you guys clear? You can type it in the chat box, yes or no something. Okay, thank you. Next. Hmm. The min-term expansion of f of PQR is equal to PQ plus QR bar plus PR bar. It's a simple problem because I wanted to present you there are different models that one may get questions in gates. That's why I thought of presenting it. I will tell another model also. We will see. Yes. Option A. Option A. Hmm. So it's straightforward, right? See here, f in this function f, p is going to be MSB, r is going to be LSB when you go for min-term expansion. Very very important. We already discussed this, right? In this product, if you see PQ, R is missing, right? How can I do that? I multiply with 1, then I will write R, this one as R plus R bar. That's how I can include R, right? PQR plus PQR bar plus here P is missing. I should write it in the MSB place, right? 1 into Q into R bar. I should write this one as P plus P bar and multiply with this. What will happen? P Q R bar plus P bar Q R bar. Here Q is missing. We have to follow the format, right? What is P is MSB, R is LSB, middle Q, right? So I can write it as 1, then I can write Q plus Q bar. And what will I write? PQ R bar plus PQ bar R bar, right? So PQ R bar plus PQ bar R bar. Now let's go for coding. P is uncomplemented form, right? So 1, 1, 1, 1, 1, 0. What is this? 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0. It is M7 plus M6 plus M6, M2, M6 plus M4. So M2 is there, 3 is not there, then 4 is there, M4, 5 is not there. M6 plus M6 plus M6 is all M6, right? It's our operation. Plus M7. 2, 4, 6, 7. Okay, this is one thing. Another model is f of PQR is written as f of PQR can be written as, is written as P plus Q. Okay, find canonical SOP form and canonical POS form. For this is very simple actually. If you see, this is OR operation, right? You know, product of sum means it is very close to this. I am not saying that is exactly the same, but it is very close. So try to find out that P plus Q, f of PQR is equal to P plus Q. What is missing? R is missing, right? I can write it as 0. If I write it as 0, I can write 0 as R into R bar. It can be written as P plus Q plus R, P plus Q plus R bar, right? A plus BC, X plus YZ. What is this X plus YZ? X plus Y into X plus Z. This is one way of writing. What you can usually also do is, you can take the same thing, PQR, that is equal to P plus Q. You can take this one, P, what is missing? Q is missing, R is missing. So you can write like this. This one can be written as Q plus Q bar. This one is written as R plus R bar. Then P. Then you multiply all the donkey work. Same thing you should do here also, right? P is missing, R is missing. So you should write as P plus P bar. Write as R plus R bar. Then try to do all that work. That's very much donkey work. And of course, you will definitely sure shot will get it. The idea is, in the gate you will have a lot of time for every question, so you should not miss out on these kind of questions, right? Right now, this is in canonical POS. So come back to the right hand side. Now, while discussion we already discussed, right? When you come to POS, let's say in the SOP, how are we doing? How are we coding it? If it is, you look at this. Uncomplemented form means 1, right? Complemented form is 0. In POS, it should be opposite. If it is here, what are we doing? If there is a complement, you will take it as 0. If there is uncomplemented, you will code it as 1. Correct? This is in SOP form. In POS, what you should do? If complement is there, you code it as 1. If uncomplemented is, you code it as 0. That is the only thing that you should take care. So here P is uncomplemented. So 0, Q 0, R 0, again P 0, Q 0, R complement means 1. So what is this? 0, correct? But this is max term, M0. This is important. These are product of sum, right? Max terms. Okay. In SOPs, what do you call them? Min term. That's why there is something like min term expansion. Okay. Now what we are doing? We are doing both min term and max term both. So here, right hand side, you look at it, M0. This is what? M1. So this is f of PQR can be written as what? Pi of 0, 1. Product, right? Now, whatever is not present there will be present in SOP. So, f of PQR can also be written as sigma m 0, 1. How many minterms are there for 3 variable? 0, 1, 2, 3, 4, 5, 6, 7, 8, correct? Out of that, 0 and 1 are over. So, what you will have? 2, 3, 4, 5, 6, 7, not 8, sorry. 8 doesn't come. So sorry. Are you getting it? So you can do vice versa also. Right? Once you find out this, you can go to this, or once you find out this, you can go back to this. You can play around with that. Okay. So that's how we can convert min term to max term, max terms to min terms, and how to get a min term expansion, how to get max term expansion, how to get canonical SOP form, canonical POS. This is how is all about it. Okay, I'm going to stop right now. It's already 6. So if you have any questions, I'll wait here for 2 more minutes. If not, I can end the session. Thank you. Just open your mic and then start talking if you have any questions. If you don't have any questions, you can leave the session. Yeah, Ramesh, that digital circuits and systems by Srinivasan from IIT Madras. You can follow that. Yes, Sai Prakash, you can do is there are two books we can do. If you want to practice problems, I can recommend anything you can do, like Sham series you can do, or you can have Morris Meno for some of the concepts related to sequential design and sequential circuit design and all those things. But yeah, there is something called Ananda Kumar, Fundamentals of Digital Logic Circuits by Ananda Kumar. You can use that book, and then you can use Sham series. There's a hell lot of material for practicing. Okay, so if you don't have any questions, who is this joining right